Hello and welcome. Today we will be using Unity to accelerate neural network development by training and testing with synthetic data. The primary goal of this network is for a robotic arm to detect the position and rotation of an object to pick up. An RCNN will be well suited for this task in both real-time performance, training time, and ease of modifying the network code to handle object rotation. The developed network extracts the region proposals from the images using selective search and a backbone of VGG16. Theta represents the object rotation and is calculated using arctan of the bbox segmentations. Unity allows us to accelerate model training by generating numerous conditions with a simple script. Conditions such as lighting color and lighting intensity, camera angles, background materials, and shadows can be randomly altered based on weights very quickly. After generating our training data, we can label the images with a tool that handles segmentation labeling to capture the object rotation values. Once our images are labeled, Python is then used to prep the data by calculating the segmentation rotations using arctan and calculating the IOUs. Once trained, the model is hosted with Flask for real-time inferencing. Let's take a look at using Unity to generate training data. Here we have 3 tables set up to randomly cycle through different training conditions and quickly generate hundreds of images. Now let's look at 2 of the core code components. First, we will prep the data by finding the rotated corners and then using the corners to calculate theta. Our model accounts for theta as an additional linear component with a single output. These additions can be seen in the model initializer and forward function. Thank you for watching. If you like this content and would like to see more, please like, subscribe, and leave a comment below. Thank you.